All right, chemistry class, welcome back. And we are going to be looking at acids and bases in this section, this unit. So I hope you're ready. If you got your notebook out and can take a few notes, that would be great. We have actually talked a little bit about acids before when we talked about some molecular compounds that ionize, that break apart into ions, and acids do exactly that. So we're going to dive in here. We're going to look at acids and bases. Acids and bases, by the way, you come into contact with those every single day. You may not realize it, but every single day you are interacting with acids and bases. Okay? So let's look first of all here at section 1 of chapter 14. And in this section, we're just going to be looking at some of the properties of acids and bases. Okay, so section 14.1, you can put the title Properties of Acids and Bases. And I'm first just going to, you don't have to write all of this down, but I'm just going to show you how prevalent acids and bases are in our life. So here's some quick examples. Lactic acid is in milk. Acetic acid is in vinegar. Phosphoric acid make tart flavor, okay, in many carbonated beverages. Citric acid are in many fruits. And then there's some others here, malic and tartaric acid. As well, and here's a picture. You can see, look at these formulas of these, okay? Formulas, they look complicated, but I'm going to show you they usually have something in common that you can use to kind of identify an acid very quickly, okay? And then bases. Bases are very common as well. So ammonia we use for cleaning. There's lye, that's a type of base. Those are also that's also used in some cleaners. Magnesium hydroxide is often used along with maybe aluminum hydroxide and sodium hydroxide are used as antacids to kind of calm your stomach a little bit. Okay, and there's some examples of common bases. And if you look closely, there might be something common in some of these formulas as well. And we're going to be talking about that as well. Okay? Now here are some properties. These I do want you to understand and I want you to know these. Okay? So the first point here is we want to make sure that we know some of the properties of acids. One, an aqueous solution of acids. In other words, if you take a compound and put it into water and it turns into an acid, and we'll talk about why that is, it's going to have a sour taste. So acids taste sour. Acids taste sour. Number two, acids are going to change the color of certain indicators. So we can use certain chemicals, whether that chemical is on a piece of paper called a pH strip, or whether it is actually a solution, we use drops of it. Those indicators are going to change colors based upon whether they are interacting with an acid or a base, or how strong the acid, how strong the base is. Okay? Those are called indicators. And acids are going to change the color of those particular chemicals called indicators. Number three, acids react with active metals. So a metal like zinc, magnesium, sodium, if you put it into an acid, it is going to release hydrogen. Here's an example right here. Barium is a metal. Here is an acid called sulfuric acid. And when you put it into that metal into sulfuric acid, it is going to release hydrogen. You'll see bubbles. You'll see bubbles. So acids react with metals to produce one of the products of hydrogen. Number four, acids react with bases. So an acid and a base are going to react to produce what? A salt and water. This is going to be really, really important for us. That's going to be one of the main things that we're going to be able to do here and look at acid-base reactions. Okay? And number five, we actually talked about this in a previous chapter. Acids conduct electric current, and that's because they ionize. When you put that particular compound, that chemical, into water to make an acid, it is going to ionize, break apart into ions, and therefore you're going to have charged particles in that solution that can conduct electricity. Okay? Now, likewise, there are properties for bases. Before we get there, let's talk a little bit about how we might name certain acids. And I'm only going to ask you to name what are called binary acids. Binary means two. So binary acid contains only two different elements. One of them is always going to be hydrogen, and then the other one is some probably non-metal, and it's going to be highly electronegative, a non-metal. I'll show you what I mean. Here we have an example. Hydrogen, there's your hydrogen. You're always going to have hydrogen. And then a non-metal that is quite reactive. This is bromine in this case. Here's how you name HBr, this acid. You'll know it's an acid because it has an H and then a highly reactive nonmetal. You're always going to start with hydro. That's because it has hydrogen in it. And then you're going to take the root of that second element name. The name is bromine. You're going to take the root of that and you're going to add to it IC and then call it an acid. All right, so this is hydrobromic acid. Hydrobromic acid. All right, let's try some other ones. Here's an H, hydrogen with fluorine. So this is going to be hydrofluoric acid. Hydrofluoric. And here's H with chlorine. So that's hydrochloric acid. Hydrochloric acid. Okay? Here is hydrogen with iodine. So this is hydroiodic acid. Hydroiodic acid. And this is hydrogen with sulfur. So this is hydrosulfic acid. Hydrosulfic acid. Okay? These, I want you to know how to name binary acids. Just two elements, hydrogen and then a nonmetal, and you have to know this naming process right here. Okay? There are other types of acids that would have a third element in it, usually oxygen, and those are called oxyacids. Oxygen, see the OXY there for oxygen. You don't need to know how to name these, but just be familiar with them. You can refer to this chart. So you'll notice that we have acetic acid, carbonic acid, we got hypochlorous, chlorous, chloric, and you'll notice that lots of them kind of have a similar setup. They have an H, and then you'll see a nonmetal with oxygens. So this kind of second part, you kind of might recognize those as some of the polyatomic ions that we talked about before. But here's CH, and then the ClO4, that's perchloric. H, and then IO3, HNO2, HNO3. Okay? Some of these are very, very well known, like nitric acid, nitrous acid, sulfuric acid, H2SO4. Here's the H with the SO4. Again, you don't need to memorize these, but just be aware when you refer to this chart, you should recognize, they all start with an H, and then they have kind of a polyatomic group that follows. Okay? This next section here is talking about some of these common acids like sulfuric acid and phosphoric acid, and talking about some of their uses. You don't need to know this, but if you're curious, you could look at sulfuric acid, nitric acid, phosphoric acid. These are some of the acids that are most used in our world, hydrochloric acid and acetic acid, and learn a little bit about those and how they're used. Okay? All right, the second thing that we want to look at here is properties of bases. Now the properties in some cases are similar, but in other cases they're quite different. So for example, number one, a base is going to taste bitter. It's going to have a bitter taste to it, unlike an acid which tastes sour. Number two, bases also are going to change the color of indicators. So when you take this pH strip right here and you put it into, that's your indicator, there's indicator on that piece of paper, that is going to change colors. You see it's changing colors when you put it into the base there. Okay? So that is going to change the color of that indicator. Bases also change the color. Different color, but they do change the color. Okay? Number three. Solutions, bases feel slippery, soapy. So different cleaners and soaps are going to feel slippery. That's what a base is. Okay? Number 4, and we said this before with acids, but bases and acids, we're going to just repeat it. When they react, they produce salt and water. Salt and water. And like acids, bases, they ionize. When you put them to water, they create ions, so they are going to conduct electricity. Okay? Those are 5 properties of bases. Okay, the next thing I want to talk about here, we're going to look at what makes, kind of defining what makes an acid and what makes a base. And we're going to name this definition after a scientist, Arrhenius. So this is how he defined an acid and a base. This is one type of definition for an acid and a base. Okay, and you do need to know this. So number 1 here, an acid, according to Mr. Arrhenius, this is how he defined it, is a chemical compound that when you put it into water is going to increase the number of hydrogen ions. So for example, if I take HCl, that is hydrogen chloride, as a compound, but when you put it into water, H2O, it ionizes, it breaks apart into ions into H plus and Cl negative. Now, in water here, this is aqueous, AQ, AQ. Now you have an acid. Now it's an acid because of the release of those hydrogen ions. Okay. By the way, in H plus means it's a hydrogen molecule that has lost its 1 electron. So all it has is just the 1 proton in the nucleus. So H plus is the same as a proton. Okay, that is a proton right there. So it's basically just has an ion, which is a hydrogen particle, a hydrogen atom that has lost its electron and is just a proton. It is now a cation with a charge of 1 positive. Okay, so this is the compound hydrogen chloride. You put it into water and it becomes the acid now. Well, now we call it hydrochloric acid. It's hydrochloric acid when it's put into water and ionizes. Okay? Now a base you're going to see a different ion that's very, very common, and that is the OH negative. That is hydroxide. So according to Mr. Arrhenius, a base is one that when you put it into water, like this is sodium hydroxide, and if you take that solid and you put it into water, it is going to break apart into its ions, sodium ion and that hydroxide ion right there. Now you have ions in there, and the production of this hydroxide ion makes this solid or this solution a base. So this is sodium hydroxide. Real simple naming for the base. You just take the metal name and add hydroxide at the end. This is sodium hydroxide, a base. Okay? So that's what you need to know about acids and bases. Acids are going to have H plus in them, H plus ion. Bases are going to have OH negative. It's just that simple. Okay? Now, I'll mention one thing here, that for an acid, and I mentioned this in the last chapter when we were talking about ionization of molecular compounds. What really happens with an acid, okay, here we have HNO3, and when you put that into water, it has an H in it right there. See that H that starts the formula? That H is going to be released, okay? So you can have H plus, and then the NO3. The NO3, those are the 2 ions that are going to be produced from putting this compound into water. What really happens though is that this water gets attached to that H plus. So if you take H2O and add it to the H plus, you get what we mentioned before as the hydronium ion. It is H3O plus. So you just take the H plus and add it to the H2O, and it is H3O plus. You may see it written one of two ways. You may see it written like this, that shows and includes adding the water and adding it to the H+, or you might just see it as, you know what, we're just going to know that water is part of this, and we're going to simplify this into the H+ and the nitrate ion. You might just see it simplified like that, leaving out the water, not worrying about the extra water here that is part of that actual equation. Okay? So you might see it like this, but know that in actuality this H+ is really a hydronium. It's attached to water. Okay? Now, some acids are strong, some are weak, and if you remember, we talked about strength of electrolytes, and it's really the same thing. So look here. The strength of an acid is basically going to be one that has lots of ions in it. Remember, that's what we said with the strength of an electrolyte. It's really no different. And what I mean by lots of electrons, or lots of ions, it's going to completely ionize. A strong acid is an acid that completely breaks apart into ions. So here's an example. Right here, this is a very common strong acid, HCl. When you put it into water, notice the arrow goes only one direction, and you're going to get H3, H3O plus, the hydronium, and Cl negative. I don't know what this little symbol is, Cl negative there, okay? Same thing with sulfuric acid. Sulfuric added to water, you're going to get the hydronium, and you're going to get this ion here, which is basically the H2SO4 without one of the H's, the H+. Notice all of these arrows go one direction. If the arrow goes only one direction, that means they are strong acids and they completely ionize. Okay? What do I mean by completely ionize? It means that when you put HI into water, all of the HI compounds will ionize and break apart into ions. You won't have any more of those HI compounds left when you put it into water. Okay? That's a strong acid. You must know that a strong acid is one that completely ionizes when you put it into water. A weak acid is one that only partially ionizes. Okay? It releases only a few ions. Here are some examples of weak acids. And it's hard to know whether it's a strong or weak acid, but here's the clue. See this double arrow right here? That double arrow tells you that the ions, some of them turn in, or sorry, the acids, some of them turn into ions, but also some of those ions turn back into the acid, back into the compound. And so it's going both directions. So it's not going to be a full ionization. It's only going to be partial ionization. This is partial ionization. Okay? So the clue is the double arrow. The double arrow means it's going to reach a point called equilibrium where you have quantities of all of these species in the solution, even the original compound. You're going to have some of that original compound in the solution. It's not all going to be just ions, okay, from that compound. So huge difference. Strong acids, completely ionized, will have a one-directional arrow. Weak acids only partially ionized and will have a double arrow showing you that all of these species, substances are going to be in existence in the solution. Okay? All right. When we talk about bases now, bases are such that they're going to produce the hydroxide ion, AOH negative. That's a base. All right? So if you take this NaOH, a solid, and you put it into water, it is going to ionize, break apart into the sodium ion and the hydroxide ion. There's your hydroxide. If hydroxide ions are being produced, then this is a base. Okay? Now, there's another way that hydroxide ions can be produced. See this right here, NH3? There's no OH in that formula. Well, how are we getting the OH negative as a product if there's no OH in the original compound? The way this happens is this NH3 steals an H from the water. So one of these H's comes over here, H plus, turning this into NH4 plus, and leaving the water turns into OH negative. Let me show you what I mean. Watch. This NH3, I'm going to write H2O as HOH. You see that? H2, there are two H's, and then the O. But I'm going to write it as HOH. This H right here joins the NH3. And as a result, when it does, it joins it as an H plus. So it's going to be NH4 plus, and then what's left behind of the water? Just the OH negative. Those are the ions that are created. You're still creating the hydroxide ion, but it happened because the H was stolen from the water, and the water turned into the OH negative in a sense. Okay? So that's a second way that bases can be formed. Either the OH is going to be in the original compound and then ionizes, or that compound steals the H from the water and the water turns into that hydroxide ion. Either case, when you see hydroxide as one of the products, you know that it is a base. Okay? Now, here are some bases. These are all strong bases. Why are they strong? Because they completely ionize, one directional arrow. These compounds, when you put them into water, will completely turn into the ions over here. Look at the OH negative. All of these produce OH negative. These weak bases, they're weak because they have a bidirectional arrow. All right, they're going both directions, which means, yes, OH negative is produced, but not completely through, not complete ionization. So there's still going to be some NH3 in the solution. There's still going to be some of this compound in the solution. Yes, there are going to be OH negatives. There are going to be some, but this only partially ionizes. Okay? Only partially. Huge difference between strong and weak. All right? All right. That concludes 14.1 and a little introduction about the properties of acids and bases. Okay? All right, let's keep up the good work and let me know if you have any questions.